Hello, this is Dr. V.C. Sontake, Assistant Professor in the Department of Mechanical Engineering, St. Vincent Pallotti College of Engineering and Technology, Nagpur. I am going to teach the course Heat Transfer. These are the objectives of this video lecture. In this video, I am going to discuss in detail the law of convection. Then I am going to define a new term called as convective heat transfer coefficient. So let us first define law of convection. It is also called as Newton's law of cooling. Newton's law of cooling. This fundamental law of heat convection was first proposed by Isaac Newton in 1701. Its statement goes like this. The Newton's law of heat convection states that the rate of heat transfer by convection from a solid surface to the fluid is directly proportional to the surface area of that solid surface and temperature difference between them. In order to understand this Newton law of cooling, let us take an example of cooling of hot plate by air. Let us consider a rectangular surface having its surface temperature at Ts. It is exposed to the fluid. This fluid I am considering as air at temperature T infinity and heat transfer coefficient H. The fluid air is flowing over the surface. Since surface temperature of the plate is more than the fluid temperature, that is, plate is hot and air is cold, heat transfer will take place from plate to the air. Let's say this rate of heat transfer by convection from the plate to the air is Q. So mathematically, from Newton's law of cooling, this rate of heat transfer by convection is directly proportional to A and Ts minus T infinity, where A is the surface area of this plate and Ts minus T infinity is temperature difference between surface and the air. Removing sign of proportionality will give the equation Q is equal to HA Ts minus T infinity. In this equation, H is constant of proportionality and it is called as the convective heat transfer coefficient. Its unit is generally taken as watt per meter square Kelvin or watt per meter square degree Celsius. Now here please remember one thing. Whether you take watt per meter square Kelvin or watt per meter square degree Celsius, the value is not going to change because to calculate the units of H, we are taking temperature difference. So whenever we are taking difference, it hardly matters whether you take degree Celsius or Kelvin. Similarly, heat flux rate small q is the heat transfer rate per unit area is equal to H Ts minus T infinity watt per meter square. In all these equations, Q is the rate of convective heat transfer in watt, A is the surface area of the solid surface particularly from which or through which convective heat transfer takes place. It is taken in meter square. Ts is the surface temperature in degrees Celsius or Kelvin, and T infinity is the fluid temperature in degrees Celsius or in Kelvin. So this is the mathematical formulation of Newton's law of cooling or law of convection to calculate heat transfer rate by convection mode. Now, in this equation also, one area is coming into picture. We are terming this area as surface area. Now, how to calculate this surface area? Let us understand by taking these two cases. Let us consider case 1 first. In this case, when only upper surface of the solid is heated, obviously by virtue of temperature difference, heat transfer will take place from upper surface only. We are not considering any heat loss or heat transfer from the side surface. Take the example of this solid surface. Here I am considering only top surface is heated. Bottom surface is not heated or either insulated. I am also not considering any heat transfer from these four edges of this plate. Maybe there may be any heat transfer, but here I am not taking into consideration. So by virtue of temperature difference, heat transfer will take place from this surface to the air. In this case 1, in order to calculate this rate of heat transfer Q, the area will be the surface area of upper side only, and this will be L into W, where L is the length of this plate and W is the width. Let us take case 2. In case 2, I am considering now, let both the surfaces, upper as well as bottom surfaces, are heated. So by virtue of temperature difference, heat transfer will be taking place from both the side to the air. Once again, I am not considering any heat transfer from these four edges for sake of simplification. In this case too, now in order to calculate heat transfer by convection, the surface area will be twice of L into W, because surface area of one side is L into W and we have two such surfaces from where heat transfer is taking place. So surface area will be twice into L into W. So this way we can calculate this surface area. Now you may ask why you have not taken into consideration any heat transfer from these edges. So I can consider, if I consider heat transfer from these edges as well, so their area will also come into picture. Under such condition, the surface area for case 2 will be twice into L into W, and let's say the height of this edge is H, so area will be, total area will be twice into L into W plus twice into L into H, because there are two such edges, plus twice into W into H, because there are two such edges. So this will be the total surface area from where actually heat transfer will take place. So this way you have to calculate surface area. In the Newton's law of cooling and its mathematical formulation, given by equation Q is equal to H into A into Ts minus T infinity. Let us rearrange this equation for H. Rearrangement will give me H is equal to Q over A into Ts minus T infinity. In the above equation, if I put area of the surface as 1 meter square or unity and temperature difference Ts minus T infinity as 1 degree Celsius, H is equal to Q. Now what does it mean? So from here I can define the convective heat transfer coefficient. So the convective heat transfer coefficient is defined as the heat transfer rate by convection from a surface of unit area to the fluid having unit degree of temperature difference between them. You take any plate of unit area and you maintain the temperature difference between that plate and that fluid as unit degree. So whatever heat transfer rate is taking place from plate to the fluid by virtue of temperature difference and convection mode, that heat transfer rate is called as heat transfer coefficient or convective heat transfer coefficient. Its unit is watt per meter square Kelvin. In the equation 8.2, if I put the value of Q as watt, A as meter square and temperature difference as Kelvin, you will obviously get this unit. Now let us talk in detail about this convective heat transfer coefficient. The convective heat transfer coefficient H is not a property of the fluid. Basically, it is determined experimental parameter whose value depends on all the variables influencing convection. It depends upon following factors. Because what happens, convection is the mechanism where fluid movement is coming into picture. So fluid mechanics and fluid properties also come into picture. So there are so many parameters related with the fluid property, with the surface property. And H, the value of H will be the effect, the combined effect of all these surface as well as fluid properties. So the first point or factor upon which the value of H depends is thermophysical and transport properties of fluid such as viscosity, density, specific heat, etc. Nature of fluid flow. Whether the fluid flow is laminar or turbulent, that will also decides the value of H. We will be discussing about laminar and turbulent flow in subsequent lectures. Geometry of the surface. Whether the heat transfer surface from which heat transfer is taking place is rectangular, circle, cylindrical or spherical or of any other shape, that also defines the value of H. Velocity of fluid. Whether fluid is moving fastly or slowly, that also defines the value of H. And prevailing thermal conditions and temperature difference at the time of heat transfer by convection. So summary of this video lecture is as follows. In this lecture, we have discussed in great detail about the Newton's law of cooling and its applicability, and we have defined convective heat transfer coefficient